Okay, do a quick run through of the end of term 3 assessment just sat. So this is the work solutions. Oops, if it actually writes that properly, let's try again. So hopefully I can get it done in under 40 minutes and get all 31 marks. So and give you some pointers on marks that might be missing. So we've got Joe rolls 6-sided dice and a 4-sided spinner. The dice is labelled 1 to 6, the spinner is labelled 1 to 4. Now Joe adds the score to the dice and the score on the spinner gets the total score. He's recorded it in this sample space diagram. The sample space diagram takes 2 inputs, the dice and the spinner, and adds them together to give us the outputs. So these are the outcomes that can happen. So that's what they've shown us. Write down all the ways in which Joe can get a total score of 5. So we're looking for outcomes with 5. Now they say they've done one for you, but it's not shown in the worksheet. So we need to actually list all 4. So that's not been done. What you list is, you just have to list the pairs for these 4 outcomes. Don't double them up, don't do too many. And what we've got is, the first one is, because of the way they've labelled it, they've said dice first, so let's list dice first. It doesn't really matter, but the pairings are dice, comma, spinner. You put them in brackets because they're ordered pairs. 2 bits make an answer. You don't lose marks for not doing that. You just clearly need to show that you've considered. We've got 1, 4. So that's 1 on the dice, 4 on the spinner. We've got a 2, 3. We've got a 3, 2. And we've got a 4, 1. Now there's only one way to do each one of them. That's why it's important you only list those 4. If you list more of them, it would change the probabilities of getting be able to get a score of 5, which is where that would be incorrect. You'd lose a mark. So what I've shown here, I've shown at least 2 correct ones. I've got 1 mark. I haven't shown you any extras. I've shown all the lists. I've got 2 marks. Next question. 2 first spinners. Spinner A, spinner B, spins both spinners and then multiplies. Notice, multiply. To give us our sample space diagram again. So we've got a sample space diagram. These are our inputs, spinner A and spinner B, and the outcomes are in the grid. And the outcomes they're interested in this time are the numbers that are, probability of the multiplication is an even or prime. So let's list all the evens. The evens we've got are 2, 14 and 18. They will come from an even number multiplied by anything. There's no even numbers coming down, so we can't do those ones. And the other evens will come from 4 times something. So you can only get the evens where you've got an even number in the headings. So the next ones are 4, 28 and 36. We then look down and think of the primes. Which primes are there? Well, primes go 2, 3, 5. Next one's a 7, 11, 13, 17, 19, 23, 29, 31, 37, 41. 17 is 41. I'm just going to do a factorise one for you. I want to check it. 41 would be a prime number as well. And now I'm getting too big. 43. 43 is prime as well. Now we're getting too far. So which ones are these in the grids? Well, we've only got 2, 3, 5. 21, 27, not prime. 35, 30, 45, they're multiples of 5. Basically, because they're in lines with these, the only places you could get primes are in this row. We can all prime candidates are in that column. So I really didn't need to know all the way up to 45. Because if it's in this column, it's a multiple of 7, can't be primed unless it's 7. Here it's multiple of 9, therefore it definitely can't be primed because it will be a multiple of 3 as well. So have a look at our two lists, and we've got a problem. We've got a double count here. Just get rid of that and just say primes are all in the 1 times. That's why we don't need these. And we've got a double count possibility. So how many of them are we looking for? We're looking at 1, 2, 3, 4, 5, 6, 7, 8. So we've actually got the total unique numbers. Sorry, n of even and prime. This U is something called a union. It basically means put the two together, but you don't double count things. So even and prime, we actually have 8 items. So to calculate the proper probability, we have the probability of even or prime is 8 out of 12. What he's got in here is this double counts the 2. And a number of you gave me solutions involving versions that give that. If you give me anything that's equivalent to 3/4, then it's incorrect because you've basically done the same problem. So next one, moving on. This was an advanced topic. Some of you won't have seen them, some of you probably won't have remembered it well from what you did. The rule with these tables is at each branch, probabilities must add up to 1 that come away from it. And if I want to create a probability for a story going that way, what we are saying is and. And to and 2 probabilities, we multiply. If we're coming down, each of these stories is unique. It's mutually exclusive to the others. Marcus wins and Marcus wins. Well, that can't happen at the same time as Marcus wins and Marcus doesn't win. They're unique. They're mutually exclusive outcomes. So mutually exclusive, we have a unique or, and we can add coming down. This is why people prefer this to the sample space diagram version, where sometimes you'll get things that can happen at the same time. So we need to work out probability Marcus wins at least 1 of the 2 games of tennis. So we want the probability here, which is win-win. Probability here, which is Marcus win and lose. Probability here that Marcus loses then wins. And the probability here, which is lose-lose. So we get to work out the story of the win-win. We have to do 0.35 times 0.35. Now, some of you might realise that if I combine these two together, the total probability here is 1. So the probability of these two together should actually be 0.35. But probability of a win, 0.35, times the probability of a lose, 0.65. If we're to add these two things together, we've got a common 0.35. 0.35 plus 0.65 gives me 0.1. Take it out, and we've got 0.35 plus 0.65. That's a 1. So the total probability of these two places is 0.35 again. We're interested in this one as well. So these are the 3 cases where there's at least 1 win. and this is 0.65 times 0.35, and you might wind up with two versions of this calculation. 0.65 times 0.35 is 0.2275. If you add all of these three together, so the probability of a win-win plus the probability of win-lose plus the probability of a lose-win (0.35 times 0.35). Show these, and you'll be getting the marks building up very quickly. You showed me that you've got to multiply and add at least two of these elements together, and you would wind up with at least 1 mark. So that on its own would be 1 mark. Plus 0.65 times 0.35. When I calculate all of that, using my calculator, 0.65. There's nothing special going on the buttons you can't see. Sorry, nothing special on the buttons you can't see. It's just giving me space on my screen. If I ever need to show you what's going on with the stats functions underneath or using pi, I'll move the calculator, which we will need a bit later. 0.35 times 0.65. And same thing again the other way around. 0.65 times 0.35, and this should give me 0.5775. Now there is another way to get this answer. All of these probabilities together coming down would have to actually add up to 1. So the total here is 1. So if I could calculate this bottom line, 0.65 times 0.65, and take it away from 1. So 0.65 times 0.65. This is the probability of a lose. That's 0.4425. And if you take that away from 1, you get the same 0.5775. Okay. 10 cost. So we can do this as a ratio calculation just for fun of it. It doesn't matter how you went about it. At the end, I want 12 as the number of chocolates. So that's money, that's chalk. How can I lead towards this? Well, from that I know that 4 is going to be £5. And once I've got 2 lines, I can add 2 lines together, or I can multiply this by 3. So I could do multiply by 3 to give me £15. Or 8 plus 4 is 12, so 10 plus 5 is 15. This works when they're all priced the same. If the pricing's changed, like we're talking about pack sizes, you have to deal with those as separate situations. But we've got £15. If you're talking money, remember if they're going to pence, always show 2 decimal places in pence, of pounds for pence. These questions, 3 marks for this is actually quite generous, because really all we need to work out is how much stuff has Adrian already got. So if he's got 10 bags of cement, each one is 25 kilograms, he's got 250 kilograms. 250 kilograms is enough. Don't need any of that. 20 bags of sand, so 20 bags times the 22.5 kilograms, that's 450 kilograms. Has he got enough? Yeah, he needs 375, he's got extra. He's got 1 bag of stone. 1 bag of stone is 50 kilograms. 20 bags, it's going to be 1,000. So 20 times 50. He's got 1,000 kilograms. That means we are short by 80 kilograms. 80 kilograms, 2 bags times 50 gives me 100 kilograms. That's just enough. So we need 2 more bags of stone. So when we fill in our answer, this is where some people make a mistake. You can't use the fractional part. We need the 2. So we need to buy 2 whole nut bags of stone. Okay. Scrolling through, dividing the ratio. I'm going to use Mr. Boothwood's extension to help me with this. It just helps build up. So 4 and 5, we want to split this in this ratio. So this is a total. So I need the total on the right-hand side of my working. This is the bit where I sometimes do differences, other things. What does it make in total? So the total here is 9. That total is 7,560. I need to think, how do I go from 9 to 7,560? So 2, 7, 5, 6, 0 divided by from 9. Same thing we've done when we're calculating percentages. Earlier starting amount divides into the end amount. And that's multiplied by 840. So you multiply each of these values by 840, you get 1 mark for each bit, or 1 mark for saying that. 1 mark for saying that, probably. And 4 times 840. Gives me 3,360. Make sure your writing is clear. And I know, just by adding up, I know that there's 4,200 left. Let's check it though. 5 times 840 gives me 4,200. My 2 parts of the answer. Question 7. This is ratio. Again, we can use Mr. Boothwood's extension, but we need to think, what does the extra part mean on the right? 3 to 5 makes, and here we're talking about how many more. So we've got males, 3, females. How many more females are there than males in this line? Well, there's 2 more females. So 12 more females in reality. How do I change? From 2 into 12, we're going to multiply by 6. Multiply by 6 is 18 and 30. So how many people in total? Add the 2 parts together. 48 people. Okay. You could actually use a version of this extension which says total. And the total is 3 plus 5 is 8. Multiply 8 by 6 gives me 48 people. That's perfectly doable. It's an alternative way of thinking. This is why I'm thinking about this proportional reasoning and lining things up all the time. Is there are flexible ways of using these, and sometimes they give you quicker methods. Think flexibly, don't think in terms of rules and formulae. Right, we've got to do this equation now. It says use trial and improvement. Trial and improvement means that if you are going to do this, you must record the values you try. Now we've already been told that 3 and 4, one's too small, one's too big. So let's make a table for our values. The value to try and the comment. So 3 and 4, they've actually led to the comment that it's somewhere between 3 and 4. We don't have to know what these numbers are. You could go to 3.5. This is an optional value. If you were using the Casio calculators, you can use their table function and do table between 3 and 4, step up in 0.1s, and it will show you a pair of numbers either side. So just to remind you how to do it in the calculator, first of all, put in your first value that we're going to try, the 3.5. Store that in my value x. We're using our memories to help us do the calculations. Most scientific calculators will allow you to do what I'm showing you. If yours doesn't, you may need a different calculator, or you've got to type all the numbers in when I type x. So let's type my formula in. So it's alpha x to the power of 3, this is there, or I can do power of 3, that means power, plus 3 times x. Now if you're doing it with numbers, you would have to put the times in, but this will calculate me a value for 3.5. That's 53.375. These extra numbers aren't really necessary because all we're trying to do is it too big or too small? This means this is too big, so we want 3.5 on the top side. Now, one little point for those of you, I made it when I did the video, this comment of too big, too small, if this highest power is negative, it's probably going the wrong way at that point and you need to look at it. The techniques that you ask for GCSE, they gloss over some of these numbers, which is why use a table method. If your calculator has a table, create the list of values to estimate and choose which ones are the correct pairings, because sometimes in certain ranges the numbers might be going down, and that does happen with cubic equations at times, not the ones you'll be given in an equation. You can play about with other numbers, but we need numbers between 3 and 3.5, so you could do any other set of numbers you like, but you should be showing me what happens at 3.2. So numbers you must try, things like 3.2. So what you can do is you can put 3.2, do shift, store into the value x, press equals, and now rather than having to retype my formula, I can go back up, select the calculation, press equals, and it now tells me my new number, 42.328, was that? So I've just got to calculate back up, 368. Those aren't truly that necessary. So we know the number's somewhere between 3 and 3.2. Now this is the bit where people make the big mistakes and lose the marks with this. So far I've only really got 2 marks. The third mark comes from making sure that I now know that it's between 1 decimal place either side. So I need the decimal place below this. What's halfway between those two? 3.1. I need to know that value to choose show which ones are possible. Because it might be between 3 and 3.1. I don't know. I need to know where is it compared to 3.1 now. So 3.1 I can store into x, press equals. Then I go back up to my equation, press equals, and I get 39.091. Again, these extra places not really worried about. That tells me that this is now too low, so we were between 3.1 and 3.2. We've got to choose between them. We can't reliably do it because we don't know what's happening, so we should go halfway. We must be halfway. It is 3.15. You can make guesses with the other ones, but they're not necessarily good guesses. Just go for the 3.15, strictly the 5 on the next decimal place, and it's going to knock out the wrong one of these. Whichever one of these is replaced is wrong, and we're left with the correct answer. So I'll put 3.15 in. And that's what we're doing, is we are reducing possibilities. Now, some of you might think, oh, just keep halving and it will go. Works if you're working in binary. Keep halving either side and oh yeah, it must be halfway between these. But with base 10, we need to get to 1 decimal place above, 1 decimal place below. And got the value in. Select my equation, and it tells me I've got 40.7. 70, as I've been doing the other ones. Let's put the last digit in as well. 701. Not worried about these extra places, but this is too small, so 3.15 less than x less than 3.2. I only want it to 1 decimal place. There's my decimal place value. I've got rid of the wrong one. So be clear what your answer is. Clearly state 3.2. Scrolling down, number 9. This is about matching the descriptions. Let's zoom out a little bit so I can see the description at the same time. So these might be a little small on your screen, but I need to see the graph as well. Temperature starts at 0 and keeps rising. So which ones start at 0? They could be A, B, C, not D, E, or F. And it just keeps rising. So the slope keeps going up and never changes. So this one stops and then changes direction. This one goes up, stops, goes horizontal, and then rises again. This goes up, stops, and then falls again. The only one which continues is B. That's their answer. Temperature stays the same for a time, then falls. So it starts with a temperature. So that gives us either A or D. Both of them are showing starts with a fixed temperature, but then falls. This one continues. D falls. Temperature rises and then falls quickly. So temperature starts at 0. Or temperature rises, it doesn't necessarily have to start at 0. But these are the rising ones. And actually it's useful sometimes to just cross them off. Don't assume that these may not be in, but we've already accounted for them with a description. They may get reused sometimes. I've not seen it in a question, but potentially they can be reused or an alternative description might be given. But cross them off to show I'm not sure I need to do that way again unless I've got nothing. So rises, then falls quickly. Rises. This stays steady, then falls at the same rate. This one rises, stays steady, and then rises again. So we're left with this one that rises, then falls. That matches the description. So these two are sort of possible. This one's got a steady state, which says probably not F, but the quickly says that this is a sharp, steep line. So it rises at 1 temperature and goes maybe 5 degrees per minute, and then drops 10 degrees per minute. It drops a lot quicker. Okay, so the steepness there suggests C. The temperature is always the same. Well, these are all varying. So we're now looking at A. Stays the same, doesn't change. Temperature is the same. All the temperature values are the same value. Temperature rises, stays the same, and then falls. Temperature rises, stays the same, rises, stays the same. That one falls. That one continues rising. So we're now at F. Let's make sure this description matches E in case there's a mistake. The temperature rises, stays the same for a fixed time, and then rises again. Yeah, that was E. So once you've got to 2 or 3 of those, right, you get 1 mark. Well, you get 2, you've got 1 mark. You get another 1, you've probably got the second mark, and then the final 2 should sort each other out. Question 10, this is a Pythagoras question. If you aren't sure what's going on, draw a right angle triangle. 2 shorter sides are 10 and 5. Which is the following approximation is closest to the length of the hypotenuse? So h squared is a squared, which is one of the short sides, plus b squared, calculate those out, and you've got 125. So h is the square root of 125. Go to your calculator. I better zoom back in, by the way. There you go. And what's the square root of 125? So 10 squared plus 5 squared. Square root of my answer. And that's 11.2. 11.18. And it says closest approximations, we're looking to one decimal place. What's the next digit say do? It says round up. Well, actually to one. So we want to the nearest, yeah, to the nearest 0.5. That rounds this up to 11.2. Which is that closer to? Is it closer to 11 or 11.5? Well, it's 0.3 here and 0.2 there. So it's 11. Right angle triangle question. Give your answer to one decimal place. There's a question in the mark scheme whether or not we should be doing one decimal place or two decimal places. Because they stated it, I have taken the mark off at the moment. We may decide to remove that because the mark scheme says remove it. Label up your triangle. So opposite B, where the right angle is the hypotenuse. The other two sides are A and B. So calculate the length BC. H squared equals A squared plus the missing side, BC, I'm going to use their two-letter coding. Rearrange, BC squared is 256. In fact, I'd stick to the 16 squared. Take that to the other side and it's going to change sign. So we're going to subtract. Because we're doing the equals, I am allowed to just swap those two over. If it was inequalities, that's a dangerous trick. So BC is, use the calculator to calculate the values. So I've got 16 squared minus 6.7 squared. And that's 211.11. And we want to square root it. So square root my answer. That's 14.5296. And 6, the 2 says round down. And then to one decimal place, I want to know about the 5. The 2 says go down, so leave it at 5. So it's 14.5 centimetres. Final question. Sorry about the typos here. It was produced by the PDF generator for this. So, how many complete revolutions will the bike make as it goes round? Now, the first thing to realise is to be able to calculate this stuff, you need to use the same units. It's probably easiest if we change the millimetres into metres. So, hopefully you all know 1000 millimetres is a metre, so that's 0.590 metres. First step, make that conversion. Second part, let's work out the length of the track. Now, this is one of the things that is coming in some maths exams. Be clear what your communication is. So I'm calculating the track first. It's made from 2 arcs, which make a circle. So 2 semicircles. And that's basically the circle. So that gives me 2 times pi times the radius. So semicircle would be pi times r, because that's half the diameter, remember pi d. 2 pi r gives us these two arc lengths. That one is when they fit together, they make a circle. So 2 pi r gives me those two curved lengths. Use a calculator when it's memory. Just trying to get the calculator somewhere where I can keep accessing it quickly, and I can't now. So 2 times shift, and you've got to find your pi button. Most of the time it's on this bottom row somewhere, times the 27. And that gives me 169.6 meters, but I'm not going to rely on that distance. That's to get maybe 2 marks. What I'm going to do is I'm going to store this in part of my distance. Store that in my distance. Now to get the distance, I also need 2 lengths of 40. So I need to also add to that 40 times 2. So I'm going to add to that, add 2 times 40. Now it gives me 249.6. And I'm storing this in memory D. It's the distance of the track. Store to memory D. 3. It's in D at the moment. I have to do the calculation again. 2 times, I accidentally got the answer button come in when I wasn't expecting it, times 27 plus 2 times 40. And store that in memory D. There's my memory D. We also need to know the distance around the bike wheel. The distance the wheel travels is not the diameter, it's the distance all the way around the circumference. So we need wheel, and that's again pi d, and we've been given the diameter. So the wheel has pi times 0.59 meters. Pi times 0.59 meters, and that's 1.85. So the number of cycles is the track divided by wheels. Store that memory C. So track divided by wheels. Store into C, and then to do my calculation, I'm going to do D divided by the number of wheels, which was stored in memory C. So the total distance around the track divided by the number of wheels, cycles, and that's going to tell me 134.68 times. And the final answer, notice, complete. If you don't turn this into a complete, just make it the number, it goes around 134 times. This 0.68, although that rounds up to 135, it doesn't make 135 rounds. It is 134. Complete means it rounds down no matter what. Okay. So the total distance tracked divided by wheels, it's a maximum at that value. It can't be rounded up, can't be bigger. That's all 5 marks for that question, and I think that's it. There you go. That's work solutions for those questions.